Thank you, and welcome everybody to a beautiful end of winter day here in West Lafayette. The sun is shining, it's nice and warm outside, and what a perfect venue to host this event today. Let me just very briefly thank the team at Discovery Park of Cliff Watalevich and Nicole Finley, Lisa Muncy, Kayla, and the director of the Policy Research Institute, Rosie Clausen. They've done a fantastic job of putting this event together. I mean, as you can see, the venue is fabulous. Thank you all so much. This was a lot of work, but magnificent job. Thank you. Without any further ado, let me introduce President Mitch Daniels of Purdue University. It is, as always, an honor and a pleasure to bring him to the stage, and I think he needs no further introduction from me, so please, President Daniels.
I'll be brief and ceremonial, but the occasion calls for it. We are deeply honored by the guests who have come to join us. I can assure you, and you'll soon know it, that you're in the company of some of the finest faculty that Purdue has, and the combination, I hope, will be not only enlightening to all of us who get to take part in it, but to people who will learn from the proceedings of this day. Let me just say how special it is, how absolutely fitting it is. Purdue is celebrating its 150th anniversary this year. We thought no better way than through an Ideas Festival, gathering the best minds in the world. And then the question was around what topics, and we tried to choose broad themes that comprise, first of all, some of the areas in which Purdue is and has historically been excellent in the technologies at which we have specialized. Clearly, that applies to today's conversation. But we didn't want this to be just an extension of the scientific and technological inquiry that goes on at this place every day. We were looking for subjects and therefore for experts and friends who might join us. We were looking for subjects that were broad enough that they would draw in the entire spectrum of the work that happens on this campus, and that meant technological questions that bring with them humanistic questions, questions of ethics, questions of sociology, questions of psychology, and on and on. Well, there won't be one all year that more, I think, precisely fits that set of specifications than this one. So I look forward very, very much to hearing what each of you has to say, and hopefully collectively coming out with a little better understanding of, arguably, the sine qua non issue facing all of us. You could make that argument, I guess, around certain topics, but this is certainly one that if humanity gets it wrong, nothing else is going to matter. So thank you so very, very much for bringing your experience and your insights to Purdue today. Have a great conference. We'll see you later when our good friend, the DNI, shows up this afternoon. Thanks a lot.
Thank you, President Daniels. All right, so we're going to start with the program today, and who better to get us going this morning than Dean Patrick Wolfe. Dean Wolfe joined the university about 2 years ago. Patrick, where are you? Oh, there he is. He joined the university about 2 years ago after spending a few years as the director of the Turing Institute in London. The Turing Institute was set up by the United Kingdom and the Ministry of Defense, among others, to really start thinking about the future implications of artificial intelligence and data science, and really get the United Kingdom and other countries around Europe with a lead in that space. Patrick was integral to starting that, and we were fortunate enough here at Purdue 2 years ago to be able to lure him back to the Midwest, where he is from originally. There's a university about 90 minutes from here in Illinois, somewhere in Champaign-Urbana or something, I think it is. where he went to school, and he got his PhD at Cambridge. And then, like I said, we were lucky enough to lure him back here to Purdue, where he's been doing a fantastic job as the Dean of the College of Science. He's a deep expert on topics related to data science, artificial intelligence, and statistics. He's a mathematician by training, and he will lead us off into the rest of the conference today. Patrick, welcome.
Thank you, Tomas, for that very generous introduction, and thanks to everyone for coming. We haven't had that many beautiful days in May so far, but it's going to be 70 degrees, and we've got a very nice vista behind us, so I think it's going to be a really wonderful day. We've got a sort of star-studded lineup of speakers, as you know, and so I'll just try to sort of, I guess, maybe frame the event just a little bit for us. As President Daniels said, we've been sort of thinking deeply this year about some big existential questions for the future. And anybody who hasn't been hiding under a rock for the past 5 years will see that big data, data science, and now more than ever AI is bringing some of these existential questions to bear on what our future looks like across not just the educational sector, but every sector of the economy and arguably of society. So that leads us to today's topic, which is, what if artificial intelligence AI wages war? We'll unpack that a little bit throughout the day, and I'll probably focus just a little bit on the ethical, legal, and social implications. As President Daniels alluded to, these aren't always the first thing that comes to a technologist's mind, but they're arguably the most important or the most critical to get right for future uses of technology. Let me give you a tiny bit of context that I bring to the discussion. As Tomas indicated, I had the good fortune to be sitting at the Royal Society, which is a little bit like the National Academies, when the then UK number 2 government official announced essentially $100 million to set up a national level British Institute for Data Science and Artificial Intelligence. The very first partner that we secured and issued a press release about was nothing less than GCHQ, Government Communications Headquarters. Many of you will know that as a counterpart to certain activities that take place here, and many of you will also know that the working partnership between these two countries is and has been incredibly strong. So I had a wonderful opportunity to host people from DARPA and other organizations coming through and looking at what it was like to stand up a multi-university research institute dedicated to this topic, right smack in the center of a global city, and that's been incredibly rewarding. We've had groups of alums now who have gone out and kind of finished the PhD program, finished postdoc fellowships, and they're landing opportunities at top places. So it's really nice to see that sort of starting to work. The kind of big second tier for that institute, and as a trustee, I still have a role in this. The big second tier has been thinking again about these bigger questions and bringing regulators, policymakers, legal scholars, and others kind of to bear in terms of how we think about sort of AI, data science, and sort of future implications. So let me just turn now to sort of the focus of today's meeting, and kind of back up a couple steps and just talk a little bit about why we're sitting in the middle of this sort of data science and AI revolution. I'm imagining probably at least some of you are aware that the algorithms that we are currently touting as some of the most successful AI algorithms to date largely were invented in the early to mid 1970s. Okay. So we have to ask ourselves, what happened in the intervening 30-odd, nearly 40 years? And if you're a little bit closer to the field, you'll know that there was a kind of relatively infamous AI winter when the early promise of these technologies didn't really live up to the hype. And the 1980s was a pretty quiet period for AI writ large, although there were certain researchers who kept plugging away. One of them recently, or a group of them recently, won the Turing Award, which is the highest award given by the main professional society for computing in the US and worldwide. And so a few intrepid researchers kept plugging away during the 1980s and the 1990s. And finally, by the end of the 1990s, things started to pick up just a little bit. That rate of acceleration continued to increase in the early to mid 2000s, and the kind of term machine learning got born around that time. And I won't say too much about that, but it's important to bear in mind that what we talk about as artificial intelligence today are really sort of these machine learning techniques that allow a computer to sort of ingest training data, if you'd like, and then make decisions on new data sets based on what it sort of learned from the training data. I won't go into too much technical detail about that, but I want to try to get to this question of, what's changed in the past 5 years, 5 to 10, to really enable such a giant leap forward in these technologies. Why are they so much more effective and deployable now than they were? Another example to bear in mind would be that of automatic speech recognition and transcription. For a long time, it simply just didn't work very well. Again, if you're familiar with the challenges of the defense community, you'll know that language transcription for rare languages is a particularly important problem in that community for reasons that should be fairly obvious. But for a long time, automatic speech recognition pretty much didn't work. This was despite DARPA and other organizations pouring billions over decades. The technology just kept asymptoting and never quite got to a better slope on that performance improvements curve. So what changed? I think there were really three things. And if you sort of think about these three things, it'll help give you a little bit of a sense of where we are right now when we think about the legal, social, and ethical implications of these technologies. So the first revolution that enabled this change was one of a low-cost and ubiquitous storage and communications. So without 3G, 4G, 5G, without solid-state drives and digital media storage, we wouldn't have a data revolution because we wouldn't be able to store and push around the massive quantities of data that are necessary. Secondly, cheap and ubiquitous sensing devices are suddenly everywhere. I mean, our iPhones and everything else they're hardly even telephones anymore. They're ubiquitous sensing devices that can do all sorts of things. And for several years, the tagline was every soldier a sensor and so on and so forth. And so there's nothing sort of new there, but somehow the economies of scale and the technological development finally brought us to the point where these sensors are really just ubiquitous. And the third big change has been the commoditization of computing. So we don't hear nearly as much anymore about supercomputers, and nobody thinks about solving the challenge of voice recognition by throwing it at a cray or something like this. It's much more about the elasticity of computing on demand. It's one more effect of commoditization to essentially be able to sort of plug into the wall and expect computing resource in the way that we've come to expect electricity or natural gas as a resource has been an incredible change. So all of these three things coming together, coupled with algorithms and mathematical approaches that were developed in the 1970s, are what has really unleashed the sort of power and promise of these artificial intelligence methods. Now that's where we are today. We are quite frankly using 40-year-old algorithms that have been refined in commercial applications of a very limited nature. So, for example, algorithms that were developed to recommend books to Amazon customers have since been repurposed to aid judges in parole decisions and sentencing. Now, the cost of misrecommending a book, the cost of getting it wrong, is obviously relatively low, especially against a baseline of no book recommendations whatsoever. So if you throw me 20 book recommendations and at least one of them is halfway decent, there's positive utility, value in creating a recommendation system of the scale of Amazon. However, when these types of algorithms get repurposed for decisions about jurisprudence or public health or the economy or warfare, then suddenly the cost of getting it wrong can be quite a bit bigger. So the first thing I think to bear in mind in today's discussion is I think the single most important thing to think about today as we consider the ethical, legal, and social implications of this field is that we are sitting at a particular cusp or at a particular local maximum. The best available algorithms today happen to be quite mathematically old-fashioned, and they happen to be quite opaque. It is not in general possible to ask the best performing algorithms today how they achieved their decisions and get an answer that is human readable. In statistics, the field in which I was trained, we put so much emphasis on the other direction that we've shied away from these techniques, and we prefer to set out models in the way that you would model a physical system, write down the variables, and do some calculations that try to show us which variables have influence on the decision that's arrived at. But these more classical approaches are simply outperformed by modern AI and machine learning techniques. So there's a very interesting technical challenge for the future generation of research leaders to figure out how we're going to get out of this local maximum of high-performing algorithms that come with a sort of automatic opacity. For the rest of us, for those of us who are not technical experts who are going to spend the next decade trying to figure that out, I think we have to be very, very thoughtful about what the consequences of this opacity might be. And this applies equally well across the spectrum, not just to the future of war and warfare, but to all the other things that I've mentioned. I think the second big thing I want to draw to your attention before I let us get on with the workshop is just the extent to which technologists have traditionally thought that if we can do something, then that means that we should. So you'll have seen already, you'll know, I'm sure, the extent to which facial recognition and other machine learning and AI algorithms are seeing widespread use in China. And you will have seen the level of investment by the Chinese government. You will know that it's a little bit like a state-backed version of Uber plus Google plus Yahoo plus et cetera, et cetera, et cetera. The entire tech sector is joined up and state-backed and quite closely connected, as we all know, to other arms of the state. You'll have seen the ways in which these technologies are being pushed out and used in ways that we might not feel agree with our approaches in Western countries to civil liberties. And I think this is an important part of the discussion about ethical, legal, and social implications. I do think our values will have to adjust, or at least we'll have to be open to thinking about reinterpreting our values in the context of these technologies. And you're starting to see that. There was an article in the major dailies just last week about police departments in the US starting to use facial recognition AI a lot more than has been in the past. I mentioned before, it's already featuring in criminal jurisprudence. I won't talk about the bias that can arise when the training data for a machine learning or AI algorithm is not representative of the population under study. Algorithms themselves aren't really biased per se, but they learn based on the data that they're shown. This is why until Google fiddled with its algorithms, if you plugged in CEO into Google Images, you would get a picture, you would get an entire page of pictures of white men. So I won't sort of talk about that very much, but I would like to say that I think we need ethicists, moral philosophers, lawyers, legal scholars, regulatory experts, and others to help us think through the deep implications of these technologies. They're so rapidly improving and emerging and coming online. And other countries are so clearly going to apply them in ways that we might feel go well beyond the bounds of our approach to civil liberties. I think it's absolutely crucial to incorporate this group of folks in the discussion. And I don't think those discussions can be meaningful without an interface that allows the technologists to talk deeply across and develop in both directions, a better understanding of the challenges that we face. So I very much hope that today will help to serve that purpose. And with that, I think I will conclude my opening remarks and turn it over to today's events. So thank you very, very much, and enjoy your day.